Have you ever considered where all the energy in the universe comes from? What happens to a ball when it's thrown into the air? Where does the energy go when a car slows down? These questions may seem simple, but they actually touch upon one of the most fundamental concepts in physics: energy. Energy, in its simplest definition, it is the ability to do work. Energy makes things move, it makes machines go. Energy also makes living things grow. Today we're going to focus on two key forms of energy: kinetic and potential. Kinetic energy, as the name suggests, is the energy of motion. It's the energy that a cyclist has when pedaling downhill, the energy of a pendulum in swing, or the energy of an arrow shot from a bow. The faster an object moves, the more kinetic energy it has. On the other hand, potential energy is the stored energy of an object. It's the energy that a drawn bow has before the arrow is released, the energy of a cyclist at the top of a hill, or the energy of a pendulum at the peak of its swing. The higher an object is lifted, the more potential energy it has. These two forms of energy, kinetic and potential, are constantly interacting and transforming into one another. Consider a roller coaster. At the top of a hill, the coaster has maximum potential energy. As it drops, this potential energy transforms into kinetic energy, reaching a maximum as the coaster hits the bottom of the hill. As the coaster climbs the next hill, this kinetic energy is transformed back into potential energy. This brings us to a fundamental principle in physics, the law of conservation of energy. This law states that energy cannot be created or destroyed, only transferred or transformed from one form to another. So, in our roller coaster example, the total energy of the system, the sum of the kinetic and potential energy, remains constant throughout the ride. In conclusion, kinetic and potential energy are the two fundamental forms of energy in physics. Kinetic energy is the energy of motion, while potential energy is the stored energy of an object. These two forms of energy interact and transform within various systems, governed by the law of conservation of energy. Now that we understand the basics of kinetic energy, let's dive deeper and explore some real-life examples. These will help us comprehend how kinetic energy is at work around us every day. First, let's consider a moving car. As it accelerates, it gains speed, and thus kinetic energy increases. The energy that propels the car forward is all kinetic energy in action. Next, think about an airplane soaring through the sky. The plane, despite its immense weight, maintains its motion due to the considerable amount of kinetic energy it possesses. The faster the plane travels, the more kinetic energy it accumulates. Now picture a simple rolling ball. As it moves, it possesses kinetic energy, which is directly proportional to its mass and the square of its velocity. So a faster or heavier ball has more kinetic energy. Consider a sprinting athlete as well. The energy that allows the athlete to move swiftly is kinetic energy. The faster the athlete runs, the higher the kinetic energy. Finally, imagine an apple falling from a tree. As it accelerates towards the ground due to gravity, its kinetic energy increases. At the moment just before it hits the ground, its kinetic energy is at its peak. So, whether it's a moving car, a flying airplane, a rolling ball, a sprinting athlete, or a falling apple, these are all examples of kinetic energy in action. Each of these examples demonstrates the energy of motion, providing a clear illustration of kinetic energy and its vital role in our everyday lives. Just as kinetic energy is the energy of motion, potential energy is the energy an object possesses due to its position or state. Now, let's delve into some real-world examples of potential energy to better understand its concept and importance. Firstly, consider a stretch spring. When we stretch a spring, we do work on it, and this work is stored as potential energy. When the spring is released, the potential energy is converted into kinetic energy as the spring snaps back to its original position. Next, think about a book on a shelf. The book has gravitational potential energy because of its position high off the ground. If it were to fall, this potential energy would be converted to kinetic energy as it accelerates towards the floor. Now picture a drawn bow. When an archer pulls back the string of a bow, the bow stores potential energy. This energy is then converted into kinetic energy as the arrow is released and flies towards its target. Consider the water behind a dam. The water at the top of the dam has a lot of potential energy due to its height above the ground. When the water is released, this potential energy converts into kinetic energy, turning turbines that generate electricity. Finally, visualize a person standing at the top of a hill. The person has gravitational potential energy because of their height. If they were to start walking or rolling down the hill, this potential energy would convert into kinetic energy. So whether it's a stretched spring, a book on a shelf, a drawn bow, water behind a dam, or a person at the top of a hill, these are all examples of potential energy waiting to be released. Each of these examples illustrates how potential energy is stored and can be transformed into kinetic energy, underscoring the dynamic relationship between these two types of energy. In the next video, we'll explore various examples of energy conversion from one form to another. For more enlightening discussions on physics topics, check out other videos on this channel. Stay tuned and don't forget to subscribe.